Welcome to qnawire.
So we're trying to find the center of mass, which means that the x center of mass will be equal to 1 over the mass times the double integral of x times rho, but we'll call it p, of x, y, d, ds. So it's a surface integral. And we know that m, the mass, is equal to the double integral of rho x, y, z, ds. So based on that, we want to recognize that our surface is the upper part of the hemisphere. So that means that ds, since z equals the square root of 5 squared minus x squared minus y squared, ds is going to be equal to the square root of 1 plus the partial derivative of z with respect to x plus the partial derivative of y with respect to x, dy dx. And what we'll end up getting as a result is 5 over the square root of 25 minus x squared minus y squared. That's our ds, and then this is, we also always have to add dy dx at the end. So since the density is constant, we call it rho, and in this case, what we'll end up getting is that since when z equals 4, we'll have x squared plus y squared equals 9 as a result. We're going to change it to polar coordinates as well. So we will make our new thing right here be minus r squared. And then this will be r dr d theta. And then since we know that our rho is constant, we'll call it 5kr. So that's what we have there, which means now we can put this into our double integral right here. Our mass is going to be this. And we know that our radius goes from 0 to 3, and polar coordinates, since it's a disk, we'll have 0 to 2 pi. Then we can bring out the 5k, leaving us just with r here. And then what we'll end up getting, since this right here will give us the square root of 25 minus the square root of 16. That's going to be the same thing as 5 minus 4, which is just 1. So then we end up getting 10. The mass is going to be 10 pi k. And then with that, we know that the center of mass will be 0 for x and y because density is constant and there's symmetry. So now we just need to find the center of mass for z, which will look like this. We know that our mass is 10 pi k times, this will be z. Since we know our theta is k, we can write this as a k right here. And our 10 pi k, so the k's will just cancel out, so we'll be left with this. And we've already calculated our ds, so we know that it will look like this. The only difference is we could change the r's and the x's and y's back. So what we'll end up having is 1 over 2 pi, because this will be a constant. And then we see that if we convert these back into their original form, we'll have, it'll be 5z over z, which is why this became 2 pi. So then we'll just have z over z, which is 1. And this is going to be dy dx. Since this is the area of a disk, we just need the area, the radius, which is 3. So we know that we'll have pi r cubed, or pi r squared, which is 9 pi. Therefore, our center of mass will end up being this part right here, will end up being 9 pi. So the pi's will cancel, and our z center of mass will be 9 over 2, or 4.5. So that tells us that our center of mass will be 0, 0, 9 halves. And then for part B, now that we have the center of mass, we also can determine the moment of inertia. To do this, we will note the projection, and if we change to polar coordinates, what we'll end up evaluating the integral to be, we have to change the limits of integration, but we'll evaluate the integral and see that Iz is equal to 140 pi k over 3.